This problem, they want us to find the sample size. You are the operations manager for an airline and you are considering a higher fare level for passengers in aisle seats. How many randomly selected air passengers must you survey? That's the sample size. We're looking for N. Assume you want to be 90% confident that the sample percentage is within 1.5 percentage points of the true population percentage. This is actually our margin of error. This is our margin of error. This is how much we want our answer to be within plus or minus 1.5%. Assume nothing is known about the percentage of passengers who prefer aisle seats. To find the sample size, go to stat, down to proportion stats, one sample, but instead of with summary, we don't have enough information to put that in, go down here to width/sample size. We want to be 90% confident, so that's 0.9 or 0.90. When we don't know the percentage, we'll always go with 50-50. That will actually give us the largest margin of error, so that can't be too small. So if you don't have a percentage, leave that at 0.5. Now the width is going to be double the margin of error. Does that make sense? You've got your proportion, your margin of error goes up, goes down, so the width of your interval is double the margin of error. This is 1.5%, so that would be 0.015, and if we multiply that by 2, we're going to get 0.03. So our width is going to be 0.03. And when we hit compute, it gives us a sample size of 3007. Exactly what we were looking for. Assume that a prior survey suggests that about 35% of air passengers prefer an aisle seat. Well, I don't know why they're going to charge extra if only a third of them want it, but let's go with that, 0.35. What does that change? It actually changed our width a little bit. Let's go back and fix that. I don't know if that'd be enough to make any difference, but I'm going to hit compute. That has reduced our sample size to 2736. Nice. So that's how you find the sample size.